All right, well, you have a test in your very next lesson, so let's go ahead and review some things in preparation for this test. We started this chapter, chapter 5, and I gave you a word problem. I might have said, I didn't, that 3 times a number less another number is 5. Or if a number is taken from 3 times another number, the result is 5. And I would say, what are those 2 numbers? And the answer is, there's no way to know. Because on its own, a single linear equation class is indeterminate. You can't determine the answer because there's too many of them. This would be graphed as a straight line, and literally every single point in a straight line is an answer. There's too many of them. So we said one linear equation is not sufficient to solve for 2 unknowns. If I want to solve for 2 unknowns, Brecken, I need another equation, 2 equations, right? So for instance, I might say that if you were to subtract 6 from 3 times the second number, it would equal twice the first number, for instance. And now we have what's called, Maddie, a system of equations. Get some graph paper out if you would, and let's find graphically the solution to this system of equations. So graph paper out. Go ahead and set up a Cartesian plane on your paper. Give you just a couple minutes to solve, and then we'll go over this together. Again, unless you were told to graph, you would never solve by graphing because it's slow and frustrating and often inaccurate, but you will be told on one problem on the test to solve by graphing. So, well, let's make sure we know how to do it. Fortunately, there is only one problem that I tell you to do that. At least for now. If you really tick me off in this lesson, we might make the whole test solving by graphing. Just kidding, just kidding. We were taking the test on April 1st. Then I might give you a test copy that had all solving by graphing on it. Then I'd give you the real test. But it's not April 1st anymore, is it? They snuck up on me without giving me a chance to think about what sort of April Fool's jokes I could play on my students. I had a physics teacher in high school. We took Scantron tests. So you fill in little bubbles, kind of like we did for the achievement test last week. And the teacher would run an answer key through. Then she'd run your test through, and anything that differed from the answer key, the computer would make a little pink mark on the side to tell you what the correct answer was. You familiar with that? Okay. Brecken knows about these. Well, anyway, there was one kid in the class who had pranked the teacher earlier in the year because he was a jerk like that, and stupid too. Well, she ran through a bogus answer key, then ran his test through. So of course, all his right answers are getting marked wrong, so there's pink everywhere on his paper, which makes it look like he did horrible. Then she runs the real answer key through and runs all of our tests through. And she just casually is walking around passing back our tests, and he gets his test and it's covered in pink and his grade is like a 30, and he's an AB student, he's an honor roll student. And he's just like, what in the world? And as she's walking around handing out tests, she puts a paper down on his desk that says, gotcha. Told you I'd get you back. The downside of that was she then had to grade his test by hand to tell him what he really got, because she couldn't actually let him have that bad grade. You know, this would be unethical. But yes, great teachers like her shaped my upbringing and my teaching style. Of course, she quit teaching and now writes for a science journal. But, you know, still. She also gave me my only detention of my senior year. I was passing a note in class. She caught me. She looked at me with a disappointed face and said, "Robert, why would you do this? If you'd been talking, I could have given you a warning." But for passing notes, I have to give you detention. I don't get a choice. I can't make the discretionary call on that. I have to give you detention for passing notes. Talking, I get to use my discretion. That was really stupid. And she gave me detention. Yeah. You lose some, you lose some. How are we coming on the system of equations? You will want to make sure you have a straight edge for the test tomorrow, since without a straight edge, it's really hard to be accurate on a system of equations. Let's take a look at these. The first one, I went ahead and went with the slope-intercept form method. We could have done a double switch and probably actually that would have been quicker, but I'd already started. Move the 5 over to negative, the y over is a positive, 3x minus 5 equals y. Either way, negative 5 is our y-intercept. From there, rise 3, run 1, connect the dots. If you do an intercept method, you still would have had the 0, negative 5, but you would have had a 1 2/3 0, which is a little awkward to try to graph. For the next one, I did go ahead and go intercepts and plug in the 0 for the y to get negative 3, plug the 0 in for the x, move the 6 over as a positive, divide by 3 to get 2. My graphs intersected kind of awkwardly here. They didn't intersect right at a point, but my guess is probably they were supposed to intersect right here and they just barely missed. So I'm going to guess 3, 4 is the solution. But how do I know if it's the solution, class? Try plugging it in, right? Plug in the 3 for x and the 4 for y. Does that work, class? Yeah. Plug in the 3 for x and the 4 for y. Does that work? So even though it didn't intersect perfectly, I can still get the correct answer and not lose points. Make sense? Did we get 3, 4 for your answer? All right, you two did Brecken question. All right, you're good to go with graphing the equations, finding the point of intersection. That said, that's only going to be one problem that you would do on the test tomorrow, since most of what we do, we try to avoid graphing at all costs. So at your seats, suppose we have this system of equations, 3x plus 4y equals negative 34, and 5y negative 6x is equal to negative 23. I don't want to solve it by graphing. So probably how should we solve this system of equations? Brecken? Probably the addition method or the elimination method, whichever you want to call it, probably be our best choice here. At your seats, take a moment. Brecken, what do we need to do first if we're going to solve by the addition method? Right, line up the letters, line up the variables. X and Y should not be lined up with each other, X and X should be. So how might we rewrite, for instance, the lower equation? Good. Keep the sign with the term. It was a negative 6x. Don't lose that negative. It's a positive 5y. Don't change that. And then once we've lined them up, Noah, there we go. Well, the idea would be pick a letter to get rid of. You picked the x. You said multiply by the entire top equation, right? So my entire top equation now becomes
6x positive 8y equals negative 68.
And the bottom equation remains for now negative 6x positive 5y equals negative 23. Maddie? Right, in this case, these 6x's are already ready to cancel. What if they were both positive, though, or both negative? Then we would need to, in one of the two equations, right? In this case, they already cancel, so we simply add the equations together. Maddie, that gives us 91, and then we divide both sides by 13, and it actually does come out evenly. We didn't memorize our 13 times tables, but this happens to be negative 7. But we're not done. Once we get one of our quote answers unquote, that's only really half the answer. Because remember, we're finding the point of intersection. We have the ordinate, we still need the abscissa. Back to Brecken. And make sure you plug it in for the y. Y equals negative 7. Don't you plug that in for x. So we have 3x plus 4 times negative 7 equals negative 34. Do you have to show this step? No. Does it hurt on the test to do so? Probably not a bad idea. Either way, Brecken, even if we plug it in mentally, we know right here we're going to get. And from there, that'll give us now 3x is equal to negative 6. Keep the sign of the greater. So x apparently equals negative 2. So our solution class, negative 2, negative 7. Once again, just like the last system that we worked, though the last one by graphing, we get a single point of intersection. What term describes a system in which the lines come together for a single point of intersection? Noah? Maddie? Brecken? Consistent. This was a consistent system. Evidently, this was also a consistent system. They came together for one particular point of intersection. Now, the equations themselves are obviously different lines, different equations. These two equations are obviously totally different from each other. We would refer to the equations themselves here, class, as being, they're each their own person. Independent, right? You own person, you independent, right? They're both their own equation, their own line, they're independent equations, but the system is said to be consistent. It is possible to have two independent, let's just take this first equation right here that we had graphed. It is possible to have another independent equation, but no point of intersection. If the lines were to run parallel, now we would describe the system, Maddie, as being inconsistent. The equations are still independent, but the system is now inconsistent. What would be our answer to an inconsistent system, class? No solution. Good, Noah. And you can spot that if you solve this way. If you happen to get 0x plus 0y, meaning x's cancel, y's cancel, equal some number other than 0. Because essentially you're getting 0 equals something. I don't know, maybe it's 5, maybe it's negative 3, whatever. Well, that would be an inconsistent system, no solution. It is possible, though, that really the equations, though they may look different, are the same thing. In which case, when you graph them, let's just take this second equation. If you were to graph another equation that really was just right on top of the first one, well, now the equations are said to be, class, dependent. Where one goes, the other goes. They're dependent, which means they intersect how many times? An infinite number. But that doesn't help us. Our solution is still indeterminate. The way you would solve this is if literally this cancel, this cancel, this cancel, you're left with 0 equals 0. Well, that's true. It just doesn't exactly help us. The solution is still indeterminate from the dependent equations. We can solve systems by graphing. We don't want to. We can solve systems by the addition method. It's also possible sometimes that we may solve by what's called the substitution method. And this is a particularly useful approach when there's a letter that is either easy to get by itself or is already by itself. At your seats, use the substitution method to solve this system. Maddie, what did you do? There we go. If this is y, then right here for y, we can replace it with a 7 minus 2x from there. And it's a bit annoying to get the fractional answer, but it's really not too bad, Maddie, because when you plug it in here, 7 minus 2 times 3 over 2, those 2's just cancel, and really it becomes 7 minus 3, which is 4. And so our answer, did we get this answer, gentlemen? All right, questions at all? The substitution method. It is also possible, in fact probable, that on the test tomorrow, you'll have a system that is just plain ugly. And while you can hate the fact that it's ugly, you still have to solve the system. What would I do in a case like this, Brecken? Good. Separate LCDs, though, right? You're not looking at 2, 3, 4, and 5 and saying, okay, the LCD is 60, right? We're looking at this and saying, well, the top equation has an LCD of, and the bottom equation has an LCD of 20. At your seats, solve. Clear the fractions out. Then once they're cleared, you can pick substitution or addition. Check your work. Make sure you multiplied everything in the top by 6, everything in the bottom by 20. Should have gotten equations of 3x negative 2y equals 4, 15x positive 4y equals 160. Could have multiplied the top by 5 and then changed the sign somewhere, but it's a lot easier just to multiply the top by 2. So I got rid of the y, multiplied the top by 2, ended up getting 21x equals 168. X was 8. Plugged that back in here for the x, moved the 20, well, no, I didn't move the 20 over because I would have had negatives on both sides, and I hated that. So I did a double switch. I pulled the 4 over as the negative, set the 2y over as the positive, get 20 equals 2y, y equals 10. Could have done the other, but I just don't like negatives. So 8, 10, our answer, and is that what we had? Any questions at all on this? Take your homework handouts out if you would, please. 7 word problems, and the biggest thing I'm concerned with is, did we set them up right? Did we get the system? Because you know how to solve systems. The question is, did you set up the system correctly? We'll have that homework handout out. Did not finish the last one, didn't know how to do it, or just forgot to do it? Okay. All right, let's go ahead and take a look at these. Go ahead and read the first word problem for us, if you would. Maddie, nice and loud. All right, Maddie, what was, how did you set this up? Did you set up a table? I mean, what was your table? What did it look like? All right. That was the number value of each, okay, and then all right, all of this very straightforward, stuff we've been doing for a while. The key was, how did you set up the system? Good, number plus number equals number. The number of tickets was 325, so the number has to add up to 325. Your next equation. And again, this is money, this is money, this was money. Money plus money must equal money. Did we have the system correct? Excellent. Probably multiply the top by a 10, put a negative through, cancel to get 5x equals 600, in which case x equals 120. That means 120 select tickets sold, 325 total. We would leave 205 general admission tickets. Is this what we had for our answers? That is not. Okay, Noah, do you have your work to know what you did to solve?
Yes.
Did you multiply by, you said you had the system, right? Did you multiply by 10 across the top? It's just so easy to multiply by 10 because you literally get to stick a 0 on the end, and that makes life so easy.
I didn't get 5x equals 600.
What did you have?
I had 5x equals 3,525.
I know what you did. You multiplied the 10 and the 10, and you said 3,850 minus 325. You didn't multiply the 10 all the way through. Okay, all right, that explains it. Questions on this? So you would have had then, no, if you had 3,525, you would have had 705 select seat tickets out of 325 total, remember. Do you see a little problem there? And that's your clue. Something's really wrong. Oh, forgot to distribute all the way through. All right, go and read the next one for us now.
A church spent $1,255 on folding chairs for the fellowship hall. Padded folding chairs cost $25 each, while unpadded chairs cost $18 each. If the church bought 60 new chairs, how many of each type were bought?
Again, trust you had your two types of chairs. You had padded and hard or unpadded, and you represented the number of each. All right, the value of each was clearly spelled out.
25 and 18.
And so the total money would have been in the chart.
Yeah, 1,000.
Okay.
Oh.
X padded chairs, $25 each. 25X, all right. And for hard, unpadded chairs,
18.
cold, unfeeling metal chairs such as we sit in at lunch, which is okay for 30 minutes, but can you imagine sitting there for 2 hours? Very bad day. Anyway, what was your system then?
25X plus 18Y equals 1,250.
Good. Money plus money has to equal money. Your other equation.
X plus Y equals 60.
And how many had the correct system on this one? All right. What did you do next? Now you multiplied negative 25. All right. So we went negative 25 here, negative 25 here, and then what did you get when you multiplied the 60 by the negative 25? Negative 1,500, hopefully. Oh. Should have been what you got. Now, my only thought, Noah, is I would have multiplied the 25, but not the negative. I would have put the negative through here so that we get all positive values. But, yeah, that wasn't the case, all right? This would have canceled, giving us negative 7y is equal to negative 245. Divide away the negative 7 from both sides. Now, the good news is you know you have to get a positive. You cannot buy negative chairs, right? So you know it's going to come out positive, and it does, of course. And here we would get 35 for y. That's 35 hard, cold, unfeeling chairs. And how many padded chairs? You did not have that correct because you didn't have the other correct. Should have been 25 padded chairs. Maddie, did you get this correct? And Noah, you had the system correct. Just again, when multiplying the 25 through had a little bit of an issue. Did you at least remember to multiply the 25?
No.
You left it as a 60. Okay. Note to self tomorrow. And again, this is why we have homework, to give you a chance to make these mistakes and learn from them. Far better to do this on a homework assignment than to screw this up on the test tomorrow. So careful with that. Brecken, questions on this one. All right, number 3, Brecken, read it for us.
The sum of two numbers is 22. The first number is 4 more than 5 times the second number. What are the numbers?
Obviously, this doesn't have differing number and differing value and all of that stuff. They just give us a first number and a second number. And, of course, we'll represent the numbers as... And so your first equation doesn't get much easier than this. The sum of two numbers is 22. The next equation, a little bit more involved.
X equals 5 plus 4.
Perfect. The first number, x, is or equals 4 more than something plus 4, 5 times the second number, 5y. Did you have this system correctly set up? All right, from there, Brecken, a couple ways you could go with this. What did you do? There we go. It's set up for substitution anyway. Why not? Now, could we bring the 5y over as a negative? Sure. Could we then change the signs to get the x's canceled? Sure. Plugging it in is pretty easy as well. What did you get then?
6y plus 4 equals 22.
There we go. I like that he added the 5y and the y in his head. From there,
And 4 divide to get... I think I did it wrong.
well, you should subtract 4 to get 18 and then divide by 6 to get 3. So if y is 3, then when you plug that in, x will be 19. So 19 and 3 should have been our two numbers. Did you two get those numbers? And Brecken, something went wrong with you and did not get that.
I think I put 18, and for x I got 3. So I think I sort of flipped them and
All right. Okay, well, I'll look at your paper real quick while. Oh, you didn't show any more work. You got that far and tried to do everything in your head. Don't do that. Do it on paper. Oh man. Okay. We go to Maddie again. Number 4.
The sequence of numbers of 6 plus 1
All right, this time instead of calling them first number, second number, they refer to these as larger number and smaller number. But we could still refer to them as. Now, Maddie, on your paper, which one did you call larger, which one did you call smaller? All right, so x is larger, y is smaller. That's important. All right, so when it says the difference of two numbers is 6, and you know it has to be this order because you couldn't take a small minus a large and get a positive. The fact that we took a number minus another number got 6 means that first number must be larger, the second number must be smaller. From there, Maddie, it says twice the larger is 1 more than 3 times the smaller. There we go, twice the larger is 1 more than 3 times the smaller. A couple ways we could go with this. What did you do next? You did what? Oh, you solved by the substitution method. So you rewrote your top equation as there we go. Move the y over to get y plus 6. And then in for the x, you plugged in the y plus 6. So 2 times y plus 6 equals 3y plus 1. I'm following you now. All right, and then what? Let's see if we can do this in one step, Maddie. We need to do 2 things at the same time. Okay, so we get rid of the little y, make it a negative 2y, and that just gives me y. So while we're moving the y to the right-hand side, let's move the to get 11. There we go. Do both at the same time. You don't have to, obviously, but you know, I'm lazy. I like to go fast. So that means our smaller number is 11. What's the larger number? 17. And 17 and 11 are our numbers. Did we get those answers? And do you have that system for number 4? All good on that front. Obviously, Gavin, if you had any questions on any of these, be sure to reach out to me before attempting to take the test. Number 5, Noah.
The sum of one number and 3 times another number is the difference of twice the first number and 7 times the second number is 35 numbers.
All right, once again, they just refer to these numbers as first number, second number. No, I'm going to assume that x was your first and y was your second. What was your first equation?
X
There we go. The sum of a number and 3 times another number is 9. Your second equation now.
2x negative 7y equals 31.
Equals 31?
Yeah.
Sound like you said 3y. 31. All right, so 2x minus 7y equals 31. The difference of twice the first and 7 times the second is 31. And what did you do to solve?
I multiplied the top by 2.
To get
2x positive 6y equals 18.
All right, so now there's our system here. We're not quite ready to, cancel stuff yet, though.
Negatives in this one.
All right.
And get 13. Yeah, negative 13.
Good, signs are the same, so we do add. Don't forget to keep the sign. And on the other side, 13, positive 13. So what is y?
1,
Negative 1. All right, then what?
Then you plug in the negative 1.
Where?
The top equation.
Go back to the original top equation, plug in the negative 1 to get, but then move it over as a, to get x is equal to, so our answer, 12 and -1 are the two numbers. Did we get those? Answers for number 5. You did not. Maddie, did you have the system correct? So the system was right. It was just right at the end when you plugged in the -1, move that 3 over, 3 plus 9 for some reason in your brain equaled 11. It's okay. A Harvard professor has recently come up with a way to say that 2 plus 2 really does equal 5. So maybe 3 plus 9 really could equal just 11. Just have to use a little bit of strange logic. So his logic, here's what it was. If you have a factory and they make round objects, and they produce 2 round objects and a half a round object, how many round objects are they making? 2, because that one's not round. You have another factory, they make 2 round objects and half a round object. How many round objects are they making? 2, because that's not a round object. But if you put it all together, what do you have? 5 round objects. No, if you're going to ignore the fact that that's half a round, then we can't put them together to make a full round either, because only a half a round plus half a round could equal 1 whole round. Totally flawed, but that's what you get for being a smart leftist Harvard professor. So anyway, these are the lengths to which people will go to try to deny basic truths. I mean, they've already denied biology, right? Certain body composition, male. Certain chromosomes in your DNA, male. Other body composition, other DNA, female. No. That's not science. He might have X and Y chromosomes and all the body parts of a male, but he says she says she feels like a girl, so we're just going to say that's not denying science, though. Anyway, I digress. Maddie, I'm not trying to lump you with this leftist professor or anything. You're just human. Anyway, the stupidity of our country. Willing stupidity, that's the thing, right? They can't just be like, I goofed up. Like, that's what, right, Matt, you would say, I just goofed up. You're not like, argue, no, 3 plus 9 really is 11, Mr. Dasky. But they willing. Anyway, it's crying shame. Maddie, read number 6 for us. All right. How many unknowns do we got? And what or who are they? More specifically, the number of coins each guy has, but we can say that Jim, or rather the coins he has, is X, and Tim, or rather the coins he has, is Y. So, how do we set up our first equation, Maddie? Says together, in that third sentence, they've collected 42 coins. So Jim plus Tim equals 42. What's the other equation? Looking at the second sentence, because that's where we got the 6 from, right? Was the second sentence? The first word of the sentence is Jim. Maddie? How do we represent Jim? Then, Maddie, it says, has collected. Now, that's your verb, right? Present perfect tense, right? Has or have, and ending with ed. That's your verb, though. That's your 6 more than Tim. How do we represent Tim? So how would we say 6 more than Tim? Does that make sense? Gentlemen, did that make sense? Did you get that system by any chance? You did. You did not. It makes sense now. Okay? If we have time, actually, yeah, the very next sentence, the very next problem is going to be very similar to this, so we'll get to see another one of these here in just a moment. But there's the way we set it up. You just have to substitute names with the X and Y here. So, Maddie, probably we should solve this. But we're going to substitute Y plus 6 in for the as opposed to x plus 6n for the y. So I think you'll get the same answers, they'll just be reversed. All right, so my top equation will become, from there, and so y equals 18. That's how many stickers, sorry, I looked ahead to the next one. That's Jack and Jill with the stickers. Jim and Tim are with coins. Who has 18 coins? Tim has 18 coins. Jim has 6 more. Jim has, and you see how if your answers, I assume, were 18 for Jim, 24 for Tim? You didn't have that either. You had Jim as x, Tim as y, and you had x plus 6 equals y. And somehow you got y equal 18, or you got x equals 18 in your work.
I got x equals 18.
So when you got the x equals 18, you're like, 18 will be Jim, but I know that ain't right. I'm putting that in for Tim. All right, word of caution, you would lose 2 points on the test. Point number 1 for getting the equation wrong. Point number 2 for not following what your own answer said to do. So just don't overcompensate. But you did recognize that Jim's got to have more. Jim has 6 more. Well, that means the equation was wrong. Does that make sense? All right, questions on that. Noah, did you get the same equations Maddie had? No. Oh, hey, we're different this time. Wrong together, but different in the way we were wrong. What did you have?
Well, I had a whole bunch of stuff.
Oh, it should have been not a whole lot. This was pretty small. I mean, there's not a lot of writing on the board.
I had like x plus 6 plus y equals 42 to the bottom.
All right, so you see how it should have been?
Yeah.
You had it? Noah, read number 7.
Jack and Jill are in competition to see who can get the most stickers on their algebra quizzes throughout the year. They have a combined total of 37 stickers. If Jack has 8 fewer than twice as many as Jill, how many does each have?
All right. Y'all been keeping track how many stickers you have? And thinks that's too much work. We're too lazy for that. But Jack and Jill are not true mathematicians. They're not so lazy. That, or when they got their stickers, they didn't throw away the quizzes. They peeled the sticker off and put it somewhere. I've had students do that before. Put them on the binder or something, so that way on their binder it's just covered in algebra stickers, because they're just so smart. And they're trying to show off and one-up everybody. Arrogant snots. But anyway, what are the 2 unknowns here, Noah?
How many stickers they have?
Who?
Jack and Jill.
Ah, so Jack and Jill would be the 2 unknowns in a sense. Technically the stickers of Jack, technically the stickers of Jill, but essentially Jack and Jill are the unknowns, right? And we should represent